So today's topic is something that almost all of us do at one time or another is establish a reliability goal and or some target that we're looking for. And one of the questions that comes up pretty regularly that I've heard is, well, what difference does that make? Why do we set a goal? Why do we go to the time and effort to establish a goal and put it into our requirements documents and in our presentations and so on? Because what difference does it make? And sometimes the goal is given, it's pretty easy to do, so it may not seem like it adds a lot of value. So let's explore that a little bit and talk about just exactly why we want to establish a reliability goal, but then also how do you estimate how useful it actually is. And so we'll explore a few of those things. Now, some people call it a goal, and I'll use that term pretty interchangeably throughout this presentation because that's the one that I'm most comfortable with. But it also could be a target, or it could be an objective. It could be a requirement. It could be specified by the customer. This is exactly what the reliability performance to be. Or it could be something that we, by one means or another, ask customers, what do they want? And sometimes that's direct and sometimes it's indirect. But by one form or another, we come up with a goal. Is how reliable does this, say, bicycle need to be? And of course, there's a lot that goes into a reliability goal in order for it to be meaningful. If we just said that this bicycle should work for 5 years, that's a piece of it, but it's not the whole picture. And is it 5 years sitting on the shelf in the garage, or is it 5 years with hard everyday use, or something in between? So we're going to set, excuse me, we're going to set a reliability goal, whether it's formal or informal. Most designers, most program teams, most equipment purchases include some expectation of how long the product should last. But the goal itself does a couple of different things, and I'll list just three of them here. It really helps us provide a direction. It points the team in one focus and gives us a marching orders. This is where we want to get to. This is our end, keeping the end in mind. Yeah, and Car, I just saw your note. Yeah, the audio is on. I think I'm broadcasting, and I got a sound check earlier that looked all right. Let's see. I'll take just a moment here. All right. Sound is good. All right. A couple people are saying I've got it. All right. Well, the second thing we use when we set a reliability goal is that we're going to do comparisons. If we don't have a goal and we do talk to a vendor or we do an internal test, we just don't. What do we know? How do we know if it's good enough or not? If somebody says, "Oh, we're 95% reliable over 2 years," okay. In some cases, that may be just fine. In other cases, that would be horrible. And without having a goal and the apportionment that comes with it, um, where are we going to be? Yeah, and benchmarking. How do we stand against our competitors? If we go out and measure or evaluate our competitors, where do we want to be in that realm? How do we quantify our comparison there? And then a third way is risk reduction, is we want to make better decisions. And having a goal allows us to evaluate whether our decisions are good or not. And it comes into play with interpreting reliability models and the uncertainty of test data. Things like that may come into place. So let's explore a couple of these things. But first, let's take a look at kind of a scenario or situation. I'm choosing bicycles because I'm actually working on a manuscript for a book on engineering management, and we're using a series of scenarios, a simulated bicycle manufacturer, a designer and manufacturing house. So I'm starting to think through a number of these kinds of scenarios with, and plus, like you're just you're you're just joined a organization, and you're the reliability engineer or manager, and the organization wants to create a new bicycle for the market. It's a new market for them. It's the serious hobbyists, the folks that go out and do races on the weekends and so on. Not quite Tour de France, but simulated Tour de France type events. But they take their equipment seriously and they take their hobby seriously. But we also want to use it as a way to explore materials and processes to make improvements for our other lines of bicycles. So we're going to take some risks here. And beyond just going into a new market, we're also taking some risks with changes to how we do our product. So we're going to set a reliability goal. So a few people have found the chat window. I appreciate that. And while I take a look at what I wanted to do is, what are the elements of a good reliability goal? Use the chat window and list what should be included in the chat window, or in a reliability goal or objective or target or requirement. And Tim, I just saw your note, reliability versus liability. Well, I'm thinking of the ignition key switch issue, or the Tesla's recent car crash. And it's going to be interesting how all of those play out. But in vast majority of cases, reliability failures tend to not lead to liability issues. Those make the news, and they make a big splash, but they're actually pretty rare. So while it's related, we tend to focus on creating products that are successful over some time. All right, so I would not necessarily include cost. Cost is an important parameter or requirement for a product. If we create a new bicycle, we probably have a cost target in mind, but I would separate that from the reliability objective itself. Customer usage is in an environment. I call it an environmental or use profile element. Good. Load and stresses, that's part of the environment and how it's used. Yeah, define failure. So it's the function. What's this bicycle supposed to do? And that may get very, very specific, other than just being a pedal manual mode of transportation, but size, weight, color, power transfer from the pedals to the hub, ability for handling, speed, stability. That list could get very, very long. But what does it mean when it doesn't work? So if the frame fractures, or if we lose a certain percentage of power transfer, each of those things could be failure. Life, Brian, what do you mean by life? What the? I'm thinking you mean. Well, you're typing, so I'll let you answer that. Warranty, Brian. Warranties, I would say, is that's where we over with the business case and cost, but it's also a time frame oftentimes. Downtime for many products and systems, like a bicycle, if you have to go into maintenance at halfway through a race, that's really not a good thing. Measurable, achievable, those SMART goals, good idea, Sean. Yeah, lifetime. So what I'm not seeing here is probability, right? So I think of it as it's like on page 1 of O'Connor and Kleiner's book on practical reliability engineering, and you see it defined in most textbooks as some function in an environment, given environment, with some probability of success over some stated duration. So let's say our bicycle is suitable for amateur racing events. and so it has to meet certain specifications on the way it's configured and the size and so on, so that it meets the requirements for entry into a race. But it also has to be able to perform at, say, the range of different speeds, ability to hill climb, the types of gearing that's placed on the book, the amount of power transfer from the pedals to the wheel, and so on. Let's say it's a North American or in European racing events, or worldwide, we could go with that, which gives us the weather. Use would be, say, regular training events plus races on weekends during seasons, and then a probability. Now, and duration. I always put those in couplets, but it is, and I had another webinar where we talked a lot about setting a reliability goal. But let's say we want the bike to work within the first month exceptionally well. So 1 month duration with a 99.9% probability of success. So the out-of-box situation is very, very good, and no failures as it's first put into service. And then let's say we have a 1-year warranty period on that. Well, our business connection is we don't want to pay too much for warranties and breakdowns and return products. So we set a financial target for the goal, and then back out, well, how many failures can we accept under the warranty clause? And so we have a probability of success, say 95% will survive the warranty period of 1 year. And then the third part is, well, we know that in this market, people tend to own bicycles for 2 to 3 years. So we want to have a reasonable reliability that it'll last some period of time for this particular audience. But we also know from market research that these products are often then put into a secondary market and may last for another 5 to 10 years. So let's say we want the frame and the structural elements to last with, say, 90% probability out for 10 years. Well, there's 3 couplets. There's our set of functions and environment, which we most likely will have greatly significantly defined in requirements documents and environmental manuals of where and how these things are used. But then we add 3 couplets of durations and probability of success. And so that would be, in my mind, how we would set a reliability goal and connecting it to our business and to our customers' expectations. So the cost part, Brian, really does come into this, where it connects to the business objectives and to the profitability of your system. But then we back out, well, what's the probability of success that allows us to meet that requirement over the durations of interest? Yeah, so the trade-off, it really is, well, what's our objectives from a business point of view or from a customer expectation point of view? And of course they're related, yet in the goal itself is, let's define those. Let's lay out a number of different sets of probabilities and durations to really enhance our understanding of what we're shooting for, what our target is. Now, the title of this webinar is on value. And so here's a quick question for you for the chat window. Well, what is value, right? If I want to have a useful, meaningful reliability goal that actually adds value, what is it I'm trying to do with that value or with this reliability goal statement? How would you define value? And I ask because I use the term a lot, and I want to make sure that we have a common understanding of that. Plus, I get a chance to drink a sip of coffee here. Measurable profit and saving, desired by the customer. Yeah, those are all good. So we're getting close. It's similar to what I looked it up on my desktop here. It has a dictionary function back in it. So I just highlighted the word value and looked it up, and it's one of the definitions is the material or monetary worth of something. And so it's related to, is this bicycle we're working on, is it going to be profitable? But when I look at the goal part, does that act make a change in the organization that improves our profitability or improves our customer satisfaction or does something else that is material in providing in enhancing the worth of say the project or the bicycle. Yeah. So and so we're doing it on purpose. We're setting a goal not just to check off a box out of design review. We're doing it for some reason because it actually provides some worth. Well, that's the question, is how do you quantify the value of a goal, right? And so you're the reliability engineer, you attended this webinar and you studied different reliability program planning and different stuff, and you know that setting a goal is useful, adds direction, use it for comparisons, can enhance different decision making. But your boss looks at you, who's not that familiar with reliability engineering, and sees that you're going to spend a day or so asking questions, talking to the marketing team, talking to customers, talking to the design team, all in an effort to set reliability goals. And your boss asks you why. Right? Well, what do you tell them? Right? So you think, well, it helps provide a direction. It gives us a target, right? And your boss is just going to look at you and say, and she's going to say, well, why? You know, we have a program plan, and we're creating a design that has a frame and brakes and steering and size of wheels and the gear chain and so on. Why do we need a goal? We've never had a goal before. So how would you, yeah. So how much money are we saved by implementing reliability goals? Now that's not the goal itself. It's actually achieving the goal. So in the past, let's say we're at 90% reliable at 1 year, and that translates to a certain amount of warranty cost. If we go to 95% and set that as our goal, well, a whole lot's got to happen to get from 90% to 95% reliable at 1 year. So the goal itself still requires something else. You know, so having the team focused and aligned, we do that oftentimes in project management, where we say there's cost, uh, time to market, and function. And then the program management team may say prioritize that for, say, for this product that's a serious hobbyist bicycle, cost isn't so much of a priority as it might be for a entry-level kid's bike. But so for function is our top priority. And we're focusing on new materials and processes in order to squeeze out a little extra functionality performance for these bikes. And cost is important. We don't want to get crazy. And time to market it's important, but if it's not a holiday purchase, it's usually for the start of the racing season, which bounces all over the world. So it could be anywhere. So how would you quantify the value of creating a goal that is to provide a direction or to influence decisions? Well, let's step through at least a little bit of logic is the way I think of it. And let's say for our scenario at this bike, as I mentioned, the performance or the functionality of the bike is our top priority. But we need a reliability goal to set a threshold, because if we pick a material that's just going to fall apart in 3 months, yet it's very, very light, it may give us great performance and it won't last very long. And so we'll say, well, that violates our threshold for reliable enough. So we're going to set a reliability goal. But the alignment piece is the focus here. And so as you think of a development process or a design process, there's lots of decisions that are made. And so, well, how many decisions are we making? Right? We're deciding materials, but not just the tube material for the frame, but wall thickness, the type of material, the processing that it has, the welding, the types of welds, the size of the welds, the any tempering or processing to the materials and so on. Then there's paint and priming and coatings and effects on wind resistance. There's, well, I don't know how many decisions there are, but let's just say the team's going to make 100 decisions a day, just to pick a round number as an assumption. But talking to the design team and talking to your program manager, you could probably quantify how many important decisions are being made on a regular basis. And then some proportion of those, maybe most of them, are going to impact reliability one way or the other. They're going to improve it or they're going to not improve it in some material way, some fashion. So let's say 90% of our decisions impact the eventual reliability performance in some form or fashion. So if the frame stiffness, which is important for transferring power to the wheel, softens, or the bike becomes more flexible, we'll get a degradation in power. And that affects its reliability for that key functional element, for example. And so deciding the material and its construction would impact its eventual degradation of that power transfer criteria. And so without a goal, the way we've been doing it up to now is how many decisions improve reliability? Now, most designers tend to design as to create a good product. They don't deliberately design a product to not work. Well, not often. But some decisions, when it's not being considered, when it's not conscious, will actually decrease reliability. We'll pick that material that degrades with power because it enhances performance in the short term. But without thinking about the duration piece of this, it's not conscious, and so we'll make decisions that actually don't improve reliability. So let's say 75% of our decisions typically improve the reliability performance of our product, and it could even be done almost unconsciously or unconsciously. But then, if we add a goal, if we increase that awareness just by having a goal available and having it in the requirements document, discussing it in the reviews, and part of the discussion of when these decisions are made, what proportion would change? How much more often would we think about reliability? Well, probably more than when it was unconsciously done. And we could do some surveys, we could do some work to figure out what would be that change when you increase awareness of a criteria for decision making. And let's say it increases it some amount, and we can make an assumption and then later measure it. But it's that change in the awareness that's the value that generates the value of setting a goal. And we can quantify on average how much does the reliability change. It might be a very small amount, but remember we make a lot of decisions. And then we can work with our team to figure out, well, what's the cost of unreliability? And oftentimes, early in the program, we may look at competitive data or our previous products or talk to the finance team. Warranty is one piece of this, but also engineering time to rework things and redesign things to fix things is often not included in warranty costs, so it may be larger than the warranty. A good figure of merit is 2.5 times retail price is a cost of unreliability. And so we can start calculating the magnitude of change in the reliability because of the difference of how often we think about reliability to make decisions, and then relate that to the the cost of unreliability in that change. So if we improve our ability to improve reliability, performance, we decrease the cost of unreliability overall. I think another piece in here would be, well, how many units are we expecting to ship? Would be another element to this. But hopefully you can see the logic of how I go about focusing on the goal itself, not necessarily the change in actual failure rate that we, just by having a goal, but in a little bit more detail of how that change of setting a goal and making it a part of our program will then change something that leads to value. So the idea is to, just as we do with what's the weight of the bicycle, one of the key performance criteria for a mid to high level performance bicycle is its weight. I think it's like $1,000 per pound, or for half a kilo of weight reduction at some point. So the very high end bikes are very, very light and very stiff, but they cost $10,000 to $20,000, whereas a bike that you buy at a local retail shop may weigh 10 pounds, but it only costs $500 for a modest road bike. And so you pay for weight reduction, and it's an engineering challenge. But the requirements document may say we're going to make a bike that's going to weigh 4 pounds. And that sets the direction for every decision we make is to, do we add this material to the bike? The airline industry, or the aircraft manufacturers, very carefully control weight, because every increase in weight of the aircraft decreases its range for a given amount of fuel that's available, for example. So like any requirements document, whether it's weight or size or whatever its criteria, reliability should be part of that, because it adds value for the team to judge their decisions and just step through a piece of that. Well, let's look at one other one. I think I've got two other examples here, but let's say you're in the throes of selecting components for the bicycle. You're working with your design team as they pick different materials and vendors and suppliers. And what's a way to evaluate the value of getting this correct the first time through? And I'll pause here for a second. How would you quantify the value of having a reliability goal, and we apportioned it out to the various major systems and components? And so we're going to go to a supplier and say, hey, we need this sprocket, and we need it to be 99% reliable over 1 year. And here's the environment loads, the functionality that we want, and so on. What's the value of having that goal when you're doing component selection? What are the ways you would quantify the value or the worth of that figure being part of that discussion, that selection process? When I teach this class, I teach a reliability engineering management class at University of Maryland, and I ask my students to quantify the value for their recommendations. And this is what they tell me, is that this is not a typical reliability question. It's not something they get asked to do. They get asked to set up an accelerated life test or calculate sample size. But what's the value of an accelerated life test? That's it. You need to be able to answer that, right? And so Jeff's alluding to is that if the vendor is providing some life data, they're doing internal testing, or they have some estimates or simulations or models, and they have cost, it's an excellent way to say, well, I have 3 vendors that each have a different reliability functional performance at 1 year or 10 years, and they're slightly different costs. Now, that leads to a natural cost-benefit trade-off of, especially in the warranty period when we're on the hook to re, uh, replace components or do repairs if something fails. And so if we go to the low-cost option and it happens to fail more often, it may completely wipe away that profitability. So the total cost, including the cost of failures, obviously should be included. But we should do that pretty much anyway. And it gives us a basis for comparing what's reliable enough to meet our business objectives. That's a piece of it. But let's take a look at, well, what's the cost of picking the wrong supplier, right? So we're going to work with a bunch of suppliers. And depending on your particular product and how complex of a bicycle you're making, it may be just at 3 or 4 vendors, or it may be 1,000 suppliers. And then those suppliers probably have suppliers too. But let's take a look at our own organization. And this is our design team. It's been making bicycles for different markets for many years. And in the past, we typically have to change suppliers later in the program. Say 1 in 10 of our suppliers we need to change. So we have about a 10%. We get it wrong. We pick a supplier, and as we build prototypes and evaluate our product, we realize that their variability is too big, or the performance of their product's not good enough, or there's some issue concerning the quality and reliability, and we have to change suppliers. Well, if we change suppliers after we start into the prototype process, and we have controlled drawings, we have contracts, we have different obligations, we may have parts that we've already purchased that we'd have to scrap, it costs money to change a supplier. We have to evaluate and bring in a new supplier. It takes time, may actually even delay the program. So we're going to look at, well, how much does it cost to change to a new supplier earlier versus later? And so there's this basic concept of, to make a design change in the concept phase is relatively inexpensive, say $10. Whereas if we have to make that change as we start production, it may cost us $100,000 to actually to manage that change, to go through the reviews, to deal with all the material issues and supply issues, contract issues, and so on. And even more once we get into production and we're shipping products to customers, to execute a change across the platform. And so the idea is if we can improve how many times we pick the right supplier concerning its reliability performance of its parts, the less often we have to change suppliers and undergo that cost. And so it becomes a cost avoidance type of scenario. So instead of a 10% chance that during this program we're going to have to change suppliers, let's say it's a 5% chance that we have to change suppliers. And if that change of suppliers typically costs us $250,000, well, we can claim that a 5% of that is avoided on average for our program. And so simply increasing the awareness of reliability, adding a reliability goal to the supply team and to the engineers as they're selecting the vendors, may help us avoid future problems. And one of the costs that we can avoid is the cost of managing and changing the supplier. And that has value, and you can quantify it. Yeah, so I see your question, Kirk. How would you quantify those future costs of vendor change? And so one way, and I've seen this done in a couple of organizations, where the finance team is actually looking at, well, what's the cost of making a mistake? What's the cost of, and similar in vein to what's the cost of opening a purchase order? Well, that actually does involve costs. There's people involved to set up contracts, to review contracts, to establish the timelines, set up databases, set up inspection routines, set up audit processes. We visit the supplier, they visit us, it takes time. All of those things can be quantified as costs. And with a little bit of work, you can probably come up with what a typical cost is to bring a supplier on board at different stages of your development process. And so they're not all going to be the same. Sometimes it's going to be rather trivial. You just open a catalog and pick a different vendor. But other times it's going to require design changes. Is nothing else, it's going to require contract changes. So each of those take time, and that adds cost. And so later in the program, then we have inventory to take care of and to deal with. And so that adds cost. So what we're looking for here is that within your organization, your procurement organization and or finance organization probably have an estimate for what does it cost to bring on a supplier. And then they can ask them that at different stages of the development process. And that can be quantified. And so what we're looking at by setting a goal is changing how often we have to change when it becomes more expensive. And so it leads to a way to quantify the value of a reliability goal. One last idea here is this: we're coming up to the final design review. We've set a goal, we've proportioned it, we've been doing testing and evaluations, we're collecting vendor data, we've created a reliability model, and we're going into the final design review. Now we've been doing, this organization's been doing final design reviews, ready to go to production, start shipping, turn on the marketing decisions for years. And we've never had a reliability goal before, and we're still in business. So it's not a do or die thing. So what's the value of having a reliability goal when you get to the final design review? We know that there's risk, and that's what this program team is built to do, is do the best in their design process and work. They do due diligence with market research and material science. But we still come down to this review where we have to sit around the table basically and say, yep, we're ready to start. Where does a reliability goal play a role? How does it help? To think about value is to think about, well, what changes when that task or activity is accomplished or this information is available? What actually changes? Right. So we're never going to have all the information we need. The best way to know if your product is going to be reliable is to give it to your customers and track it for as long as you can. When we're coming out of the design, we may have done some prototype work, we may have done some evaluations and testing, we may have tested to failure, may have even done accelerated testing. We may have done a beta program for 3 months or 6 months with a variety of different teams that were willing to use this bicycle and put it through its paces. And we probably learned a lot through that entire process. But did we catch everything and fix it? Or are we aware of how and what's going to fail and when with some accuracy, which is probably going to be unknown, the amount of accuracy we have. And so having a reliability goal doesn't mean that you've actually achieved it. And the measurement systems and estimates we make are almost always certainly wrong. Yet, to some degree, we still have to make a decision. Well, there's a couple ways we can make errors in this decision. One of them is that there's something lurking in the system that's going to cause a complete shutdown of production and redesign, and we miss it, and we decide to ship anyway. And so there's the error of shipping a bad product, but there's also the error of deciding to delay and redesign something, and rework something, improve part of our process, when we actually would have met our reliability targets and goals anyway. Right? So not having a goal We don't know whether a model in product testing and simulations we do says we're at 95% reliable at 1 year. We don't really know whether that's any good or not. Sounds good. But if the customers would only accept in the marketplace a 99% reliable product for 1 year, it's a disaster. On the other hand, if they're willing to take a higher amount of failures for the extra performance, and they would have accepted a 90% reliable product, we over-designed it from a reliability point of view. Not that extra reliability is a bad thing. A little margin there is probably not bad. Yet, if you're just given, we're 95% reliable at 1 year, how do you evaluate that? How do you know that it's okay? And so if you don't have a goal, you're going to make a decision based on performance and cost and time to market. And it's no major reliability issues are known. So we're going to ship it anyway. And you're going to have a probability of making one of those two errors, shipping a bad product or delaying a good product. Now, most of the time, we're going to be fine. The product is going to be fine. But it's changing the information that allows us to judge that model results, the testing results, the information we have results, allows us then to say we've reduced our probability of making one of those two errors. And so let's say the product line is worth $10 million to our business and revenue, and we can estimate the impact of our past reliability issues. We've shipped products before that we've had to bring back and redesign, maybe even have done a recall. But if nothing else, we scramble a big proportion of our engineering team to solve some problem, or the operations team retools a bunch of equipment to maintain production capability to fix a problem. Those are real costs. And we can take a look at how often that's happened in the past and what those costs are. And so if we can change the frequency of making that mistake by judging our results to a goal, we can avoid those costs of shipping when we shouldn't have. Vice versa, every now and then we are a little more risk adverse, and we say, no, we need to hold. 95% doesn't sound good enough. Let's keep working on issues. When in fact, if we would have set a goal that is based on our business models, based on our customer expectations, and based on setting a reliability goal to represent what we're trying to do, we may have, on occasion, said, oh, we're good. But we can calculate the cost of lost revenue by delaying a month, plus the cost of our development team for the extra month. And so it takes a little bit of digging to get these numbers, yet the ability for us to make better decisions and avoid one of these two mistakes has a value. And so hopefully you can see some of the logic that goes into focusing on just the presence of a reliability goal. It gets a portion, it's broken down and built into our system. It's discussed on a regular basis. It's included as a criteria for decision making, which is what I think of as a reliability goal, or like any specification. It helps us make better decisions. And that's the essence of it. And there's other ways that we could get value out of just having a reliability goal, having a reliability model that breaks down that goal. But the notion is, or the idea here is, that we don't set requirements for a new product just to fill the document. We do it because it actually provides something of worth. And being able to step through that and articulate why it's worthwhile to set a reliability goal, why it's worth discussing it as you go through the program, that's where the value gets created. And being able to estimate the potential value, or vice versa, to look back at a program and say, this is how it made a difference, then we start to show that what we're doing as reliability engineers actually is of worth, is of value. And that's useful if you're being evaluated for, well, what good are you, or what have you done lately? But it also helps the organization recognize that, from our point of view, paying attention to reliability actually provides a material and monetary return. So the investment in setting a goal might take you a day to create the reliability goal and tie it to your business and to your customers. Well, that's a day you could have been doing something else. But if you set a goal correctly and use it regularly, it's probably the best day of that you could have. It's the best thing you could have done for that day, is set that goal. But unless you can convince other people that it's worthwhile and actually show them when you look back at a program, you'll continue to receive resistance to spending time setting a goal, especially in an organization that's not really accustomed to reliability engineering. Now, I've made it this far, and I've only got 10 minutes or so left, and I'll take as many questions as you have. But I've been talking about reliability goals, and not once have I mentioned that 4-letter acronym, so I'm kind of happy with myself for that. So I'll try to avoid it for the rest of the event. So what do you do now? Right? Well, figure out what's important to your organization. It might be time to market, it might be cost, it might be weight, it might be performance or some functional element. But it's also what's important to your decision makers. Is it risk? Is it certainty? Is it customer satisfaction? What is it that's important to the decision makers? And are they adverse to making mistakes? Is there an internal dynamic that really punishes people when they make a decision? Are they risk adverse? Or vice versa? Is there a reward system if they're taking risks? Well, can you quantify that? And what's the impact? Is that a reasonable risk or not? Or is this the right trade-off with cost? For example, what's the cost of going down the road? So whichever scenario, and I just outlined 3 of them, but there's a lot of other ways you can quantify the value of a reliability goal or any reliability task, is, well, what information do you need? And it might be working with marketing or procurement or program managers, the engineers. Ask. Go find the information you need. In some programs I've worked with, I typically ask the question of, well, what's the cost of warranty per unit shipped? And the reason I do that is that it puts the cost of warranty in terms of the cost of every component in the product. And I learned that from Dick Moss when I was at Hewlett-Packard. He said, imagine a laptop, right? It costs us $2,000 to put it in the box with all of its materials and components and connect, bits and bobs and pieces that we pay for that goes into this thing. Put all that in there. And imagine that you take out of a crisp, brand new $100 bill and you put it right on top. Because while that individual laptop may not fail, if the number of laptops that do fail and have a warranty claim and cost of unreliability, on average, every one of them is shipping with a $100 bill in it. And oftentimes when you do that exercise, you find out that the warranty is one of the most expensive components of your system. But sometimes it takes some real work to find out, well, how many units are you shipping and what's your warranty expense for that product line? And that's all you really need to figure out what's the cost per unit shipped. But then what's the cost of making a change, a design change earlier versus later? It's a great argument for doing halt testing or FMEAs, is to identify areas of weakness or areas for improvement earlier in the program. It might cost us $20,000 to get a group of people together to do an FMEA or do a halt test, Well, what's the value of that? Well, if we can fix something earlier versus later, we can avoid the cost later. It's that kind of thought process that allows us then to quantify the value of a reliability goal or of any task that we're doing. Yeah, Tim, I think, and that's kind of my thought process is to work out some real numbers and set up a case study, essentially. So watch for upcoming articles on Ascendo reliability, where I'll more than likely have to do some of that. And so on this screen, there's some links. I think they're active. The white text is active links. But let me pull up the download slide, and it has the links also. And in the chat window or the Q&A window, uh, we've got a few minutes here if there's any questions. And thanks everybody for participating in the chat window and adding some material there and joining me today for the event. And as I mentioned earlier, there's the recording of this will get posted in another day or two to reliability.fm underneath the Ascendo Reliability webinar series. Plus, it'll be added to the podcast sequence for that show of the same name. And so let me know what you think. Is this, does it add value? This concept of figuring out what the value of something is, especially the goal. Thanks, Aziz. Appreciate that. And I do see a handful of regulars on the podcast on the listing here, so thanks for coming back. Kirk, you're always here, and thanks for the questions and comments. Paula Rhea, I think that's pronounced that way. I'm sorry if I get it wrong. Sean, Tim, handful of others. Ignore. Sorry if I mispronounced that. Gregory, you almost always come in with a 2 behind your name. Not sure what that's about, but welcome. And if this is one of your first sessions, thanks for joining. And for everybody, let your friends and neighbors know if you think it would be of use to them, if it would be of value to them, no pun intended. All right, so I'm seeing a bunch of thanks and appreciate that. I'll stay online. I'm going to turn off the recording, and I'll stay on the line for if anybody does have any questions. Be happy to talk to you about this particular topic. Oh, I almost forgot. There's a book. It's free if you're a member of Ascendo Reliability. Look under ebooks, and it's called Finding Value. And it lists a number of different approaches for any reliability task of how you would go about quantifying the value of it. And so I think there's 11 or 12 different ways to tap sources of value. Everything from reducing failure rates and the effects it has to saving engineering time, for example. It could be a number of different things.